In this section, we are going to talk about the intercept form of a quadratic function. Here, the intercept is meant as x-intercept. So let's first try to understand what exactly are the intercepts. It can be either x-intercept or y-intercept in general, but in this particular situation, we are only talking about the x-intercept. Let's try to understand what's the x-intercept. Let's say certain functions graph intersects the x-axis somewhere here at 3. So we would say that the x-intercept for this function is 3. Similarly, let's say there is another function, let's say it's a linear function. It intersects the y-axis at certain point at 4. We would say that the y-intercept for this function is 4. So a quadratic function may have 0, 1, or 2 x-intercepts. So we can represent a quadratic function in the intercept form only if we have at least one x-intercept. So the equation of the intercept form is given as y equals a times x negative p times x negative q, where p and q are the x-intercepts. Now, how to get the axis of symmetry? Axis of symmetry is the line that intersects the graph and it divides the graph into two equal halves. So the equation of the axis of symmetry, just because it's a straight vertical line, so it's given by x equals something. So the equation, the formula for that is x equals p plus q over 2. Using this formula, we can figure out the axis of symmetry of the quadratic function in the intercept form. The leading coefficient concept is similar to vertex and standard form. If it's positive, the graph opens upwards, or if it's negative, the graph opens in the downward direction. Let's have an example now. First of all, we'll compare this equation with the intercept form of a quadratic function, which is y equals a times x negative p times x negative q. So as we compare negative p with positive 3, the value of p is negative 3. Similarly, as we compare negative q together with negative 1, we get q equals positive 1. So these are the two intercepts of the given function, negative 3 and positive 1. It means the graph will intersect at negative 3 and positive 1 at x-axis. Well, after finding out the x-intercept, we need to find out the axis of symmetry. For finding the axis of symmetry, we have a different formula now. The formula is x equals p plus q over 2. So we can substitute the values of p and q. P is negative 3, q is positive 1. We simplify this, it's going to be negative 2 over 2, which is negative 1. So x equals negative 1 is the axis of symmetry. Once we got the axis of symmetry, we have got an idea about the graph of the function. So let's plot it. I've calibrated the y-axis as 2 units at 1 square just because we have some larger values. We need to accommodate them in this line, so we assume some relevant scale. On the x-axis, it's okay. We have lesser values, so it's okay. We can actually manage that. So the very first thing we'll do is we can plot the x-intercepts as well as the axis of symmetry. So the one of the x-intercept is negative 3. So we can plot here. The other x-intercept we got is positive 1. So we can plot it over here. Also, we've got the axis of symmetry as x equals negative 1. It means that it's a straight line, straight vertical line that intersects the x-axis at negative 1. After finding the axis of symmetry, we also need to figure out the vertex of the given quadratic function. So for getting the vertex of the quadratic function, we'll substitute the value of x into the given equation. The equation is y equals 2 times x plus 3 times x negative 1. We need to substitute the value of x as negative 1. Let us substitute it. 2 times negative 1 plus 3 times negative 1 negative 1. We'll simplify this. It's going to be negative 8. So we can write it as an ordered pair x comma y, that is negative 1 comma negative 8. It means that the vertex or the turning point of the quadratic function is negative 1 comma negative 8. We can plot it. Negative 1 comma negative 8 is plotted here, and then after we've got an idea about the function, but at least one more point is needed here to have a proper graph. So we can assume certain value of x, and then we can figure out the corresponding value of y, and then we'll be able to plot our graph. So the equation, let me just write again, it's y equals 2 times x plus 3 x negative 1. Let us say x equals 2. We assume we can even have a table here, and then we can assume the value of x and we figure out the value of y and then put it there. But just because we already have certain points, so we don't really need to draw a table. We can get a single point right away like this. We substitute x as 2. Y came as 10. So the other point we can consider as 2 comma 10. Let us plot that here in the graph sheet. So 2 comma 10 lies somewhere here. So by symmetricity, we can have its image at the other end at 3-unit distance from the axis of symmetry. So 1, 2, 3. Okay. So we've got sufficient points to plot the graph. Now it's time to connect them with a smooth curve. So I used a tool to plot this graph, and one thing is also clear from this graph: just because the leading coefficient of this equation is positive, that's why the graph is open in the upward direction. So that's all about it. Thank you.